Hello everyone. Today we'll be doing some alignment. For aligning sequences, we can Google and find different alignment tools from Python command line, and that will use different tools like muscle, cluster W, or whatever we want, and then do the alignment. But we'll do something different today. We'll align multiple FASTA files like you can see over here using the command line. We have 3 sequence files in this folder and they have different sequences in there, and regardless of the sequence files or the sequence ID, will align them uh, in their own respective files. So for this, we'll make sure that our pathway is in the same like folder, so making sure that we don't have to type all the path, and we'll import the global command line and use that global command line to read a file name with a certain extension. Here we are using .fas *.fas extension as a file name to be read. To keep this loop running for the alignment, we'll open the file name as f so that it will read all the 3 files. Another important thing to keep in mind is that we don't want to have output file overwriting our input file. If you want that, then you can discard this step, but for now we'll add aligned.fas to the file name. Sorry, it's fas to the file name, and write output to the new file name. Old file name that has this aligned.fas appended to its name, and that will be our new output file. Alright, so now our in file will be the input file, as we are changing the file name to the string at first. Make sure we will change the file name as string. And now we will be using the alignment tool that we can find in Python. For now, let's use the MAFFT command line that will take our in file as an input command, which is the file name in the loop from the global command line. But at first we are importing the command line from the bio.align.application. So it's here mafft.cline, the maft command line will take our output, take our input, and we want to print the maft command line over in the previous line. This will help if we have to troubleshoot. This will print out which file in the program it was working at first. So, and if we are aligning like thousands of file name at the same time, we can find where the error was, right? This will help us to troubleshoot. So yeah, that was the thing I was trailing previously. So the next thing we have is that maft command line will export its output as std out. So we need to write this output from std out into the output file that we had described previously. So that maft command line over there, so we want that std out. So for this we'll use our input file with the new name that was appended and make it as an output, so that our output will have the input plus aligned, and we will open and handle to write that std out into that file name, into that output that will create. That will be a writable file. So we will have that as a handle, and in our handle will be written is the std out. So each output from each file name will be written to the new file name that has the input file name plus that align.fast. You will see in a while what I'm talking about, which sounds really confusing to explain. So let's run to see and hear what is the output over here, and I'll show you in a while. So that is just like, just a second, just making sure our codes are correct, no spelling mistakes and everything. So let's run and see. Okay, so it printed out that our all three files were being read using the math command line. So let's go outside to check our folders. So our output folder has an output that has a.fast and has align.fast as its output file. Let's look at the file which shows our align output. This was already a line file, so you might not see a big of a difference, but you can try with your lot of files, and this is really helpful if you are working with multiple genes and multiple alignment that you have to do at the same time. This will save you a lot of time. So the neat thing is, like, you can use different tools that are available publicly that are not being specified as a Biopython tool, but you can use that and then think of how we can use those tools for our sequence based analysis. So like we can use we are just using like multiple alignment tools to do that. All right, thank you for now. Thank you for watching the video. Bye bye.